is the waves topic. This section is called the electromagnetic spectrum. And what we're going to be doing in this section is taking a really good look at a chart on the reference tables that's called the electromagnetic spectrum. Now, you can find various versions of this type of chart on the internet. But what we'll be doing is looking at this one specific chart, and then you can apply what you learned here to either this chart or to any other electromagnetic spectrum chart that you feel like using from the internet. So here we go. Now, in order to get the most out of this little video here, you're going to have to print out the chart that says the electromagnetic spectrum. All right, the chart says the electromagnetic spectrum. All right, right across the top. You can print it out from this website, or you can go to NYS Regents.org, and you can go to reference tables, the physics reference tables, and print out either the entire reference tables, or you can print out this chart there. All right, so when they say the electromagnetic spectrum, they mean all the different kinds of light in the universe. Now, we know that light, we've already learned in this topic, that light is a transverse wave. And as a wave, light has a frequency, light has a wavelength, right? And light travels at a particular speed based upon the frequency and the wavelength. The speed of the light, v, is going to be equal to the frequency times the wavelength. All right, so again, we know that light has a frequency and light has a wavelength, right? That's when it's acting as a wave. We also know that light can act as a particle, but that's not going to come into this discussion as much. All right, so on the chart, we see wavelength across the top. So wavelength is listed across the numbers on the top of the chart. Now, to the left, we see the number 10 to the negative 13. So that's a very small number. Now, over on the far right, we see the number 10 to the fourth. That's a much bigger number. So what we see is that as we move to the right on the top of the chart, the wavelength is increasing in that direction. Then you have some different types of light named. I'll read them very quickly and we'll go into more detail later. You have gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves, and longer radio waves. Listed the types of light from left to right. Now, below that, you have numbers for frequency. Right, so the frequencies are listed on the bottom of the chart. And what you find is that the number for frequency on the left side is 10 to the 21st, so that's a big number, all right? And actually, let's do it the other way. And over on the right here, you've got the number 10 to the 5th, which is smaller than 10 to the 21st, a lot smaller. So as you go in this direction, the frequencies, all right, are decreasing. The frequencies are decreasing as you go to the right on the chart. So right away, we see that there is an inverse relationship between wavelength and frequency. As the wavelengths are increasing, the frequencies are decreasing. Now, let me draw a quick little picture, a quick little sketch of a transverse wave that has a small wavelength but a high frequency. So over here, I'm going to draw a small wavelength with a high frequency. All right, so that would be the kinds of light that are to the left on the chart. A very short wavelength. Look at how small it is from crest to crest. There's your short wavelength. All right, and the frequency is high because if you put your hand here and you count how many crests go past your hand in a specific amount of time, it's going to be a very high number. A lot of these little short wavelengths, right, a lot of these crests are going to go by very quickly, so that would be a high frequency. Now over on this side, we're going to draw a big wavelength. Right, here's long wavelength, and this is not supposed to be to scale by any means. So this is a long wavelength. You can see from crest to crest is very long. So the wavelength is high because it's a long wavelength. And if you put your hand here, not as many crests are going to go by in the same amount of time, assuming that these two waves are traveling at the same speed. So over here, we have short wavelength, high frequency. Over here, we have long wavelength, low frequency. All right, let's write that in. All right, over on this side, we have short wavelength and high frequency. And over here, we have long wavelengths and low frequencies. So that's a quick little introduction to what the chart is showing. All right, next we're going to move on to the types of light by name. The names of the different types of light and their characteristics. Which ones belong on this side with short wavelengths and high frequencies? Which ones belong on this side with long wavelengths and low frequencies? Now, let's go through one more time the wavelengths and the frequencies on the chart. All right, again, you have to have a copy of this chart. You have to be looking at this chart. All right, it's going to be very difficult for you if you don't print out a copy of this chart. And you can print it out from this website, or you can print it out from the website NYS Regents.org. All right, go to that website and look under reference tables and print out either the entire reference table, 6 pages, or just this chart, which is 1 page. All right, so on this chart, which is called the Electromagnetic Spectrum, you've got wavelength on the top. Those are the numbers across the top. And on the left side, you've got short wavelengths, small numbers. On the right side, you've got long wavelengths, large numbers. Now, the numbers across the bottom of the chart are frequencies. Frequency. And on the left side, you have high frequencies. These are large numbers. And on the right side, you've got low frequencies. These are small numbers. Now, keep in mind that high frequency, according to this equation, right, E equals HF. When the frequency is high, the energy possessed by the light is going to be high. So what you're going to find, since high frequency light is high energy light, high frequency light in general is more dangerous than low frequency light. Because high frequency means high energy, so when it strikes objects, it tends to damage them. High frequency light, because of the high energy, tends to break molecules apart, tends to cause burns, and it can cause cancer. So again, the dangerous, generally speaking, the dangerous types of light are going to be on this side of the chart. Short wavelengths, high frequencies. They're going to look like this. Zzz. Okay? Zzz. They're going to look like that. Short wavelengths, high frequencies. Now, the types of light that are generally considered harmless are going to be on this side of the chart. They're going to have long wavelengths, right, and low frequencies. Right? All right? So, let's erase that. Because what I want to do now is name the different types of light and put the ones that are generally considered dangerous on this side where they belong. You've got visible light, the light that we see, the rainbow, in the middle, more or less, and toward the right side, the kinds of light that are generally considered to be safe over on that side. The long wavelengths with the low frequencies. So, let's look at the different types of light on the chart. The shortest wavelength of all, with the highest frequency, is called gamma rays. All right, that's gamma. Gamma rays. Now, there is some overlap. If you look on the chart, there is some overlap. I'm going to have a little less overlap when I draw them up here. But of course, the chart is correct. All right, mine's just like a little picture. All right, X-rays come next. X-rays. Now, you know that X-rays are dangerous because when you go to the dentist and get an X-ray, they put a lead cloth over your body to protect your body from the X-rays. Right? You don't want to damage, especially your sexual organs. All right, so they put a lead apron over your body when you get an X-ray at the dentist because X-rays are dangerous. The next type is ultraviolet. Now, you know that ultraviolet is dangerous because it causes sunburn. Right? A little bit of ultraviolet is going to cause a suntan, but too much ultraviolet is going to cause a sunburn. And you could, if you laid out in the sun long enough, you could give yourself third-degree burns. It would be terrible. All right? Ultraviolet can be very, very dangerous. Now, the next type of light is visible light, and we know that visible light is broken up into the following colors. Now, the violet is going to be close to ultraviolet. Right? So violet is going to have a shorter wavelength than the other ones that I'm going to put up here. Violet, then blue. All right, you know the colors of visible light. It's the color of the colors of the rainbow. But on this chart, they're going to be backwards. They're going to start with violet and then blue. All right? And then green. Right? And yellow. You might be able to see that. Yellow. And orange. And red. Now, I skipped indigo. All right? The color between blue and purple. All right, so here's your visible light. All right? Red, orange, yellow, green, blue, indigo. We skipped violet. All right? Let me just put, all right, red, orange, yellow, green, blue. Indigo would be between violet and blue, all right, and there's violet. I'm just going to erase, all right, you know that that's Roy G. Biv, okay, and normally you would write it in the other direction, all right, but violet has the shorter wavelength, red has the longer wavelength. Violet light would look like this, short wavelength. Red light would look like this, long wavelength. Okay, and the others in between would fall in between. All right, now, after red, a longer wavelength than red would be infrared. So infrared is going to be over here. Infrared. And then comes microwaves, like the microwaves in your microwave oven. Microwaves. All right, and then you've got radio waves. And somewhere mixed in there would be TV waves. All right, the waves that we used to transmit television signals with. All right, and longer, all right, long radio waves, I'll just put RW, long radio waves on the far right. All right, so from the shortest to the longest, the types of light. All right, now let's remember that this here is visible. All right, the colors are going to be visible light. I'll draw that up here. Visible light. All right, from the shortest to the longest, the types of light are gamma, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves, and some television waves mixed in there, and longer radio waves. All right? So these are all the different types of light. Now, I said earlier that the light on this side, the high frequency light, is going to be generally considered the dangerous light because of this equation, energy equals Planck's constant times frequency. High frequency means high energy. When high energy light strikes an object, it can damage the object, whether it's a cell in your skin, right, or it's a molecule up in the sky. High frequency, high energy light can break apart molecules. For example, the ozone layer, right, gets broken apart, and the ozone layer protects us because way up high in the atmosphere there, the ozone molecules are getting broken apart, and that light does not reach down to us. It gets absorbed when it breaks apart the ozone molecules. Right? So high frequency light is high energy light, and it's dangerous. It damages objects when it comes into contact with those objects. Now, low frequency light, right, over here, these are generally considered to be harmless, relatively harmless forms of light. I will talk more about that in just a minute. Now, look at the dangerous types of light. Now, we know that visible light, right, as long as you're not staring at the sun or staring at a laser, all right, visible light is generally considered to be safe. All right, all the colors that I'm seeing in front of me right now are not harming my eyes. All right, so ultraviolet is the one that causes sunburn and can cause skin cancer. All right, X-rays definitely can cause cancers. All right, gamma rays can be lethal. X-rays can be lethal. All right, so all these ones over here, these are the dangerous ones. They're high frequency, they're high energy. You don't want to be looking at an ultraviolet light. All right, that's damaging your eyes. All right, you want to be covered with a lead cloth when you go to the dentist so that you're not getting X-rays on your body. All right, only the X-rays in a little part of your mouth where you want to take an X-ray of a tooth or a section of teeth. All right, and gamma rays, we definitely don't want to come into contact with those. Very, very dangerous on this side of the electromagnetic spectrum. Now, on this side, infrared. What is infrared? Well, I'm giving off infrared radiation right now. What is infrared radiation? I'm giving off infrared radiation, so are you. That's right, it's heat. All right, infrared or thermal radiation is called heat. All right, and we generally consider these ones over here to be safe. All right, microwave ovens, you can talk in the kitchen, you can stand in front of the microwave oven while it's running, it's not going to hurt you. All right, radio waves are all over the place. All right, they're carrying radio signals from the radio antenna to your radio in your car. They're safe. All right, television waves, long wave radio, again, these are all considered to be safe. Now, if you get caught in a fire or you burn your hand, then it's too much infrared, and that's not safe. All right? If we were to put you inside the microwave oven, don't ever do anything like that. All right? Obviously, that would be very, very bad. All right? All of this is relative. But generally speaking, under normal circumstances, these types of light listed over here are safe because they are long wavelength and low frequency. They look like this, all right? The dangerous kind of light looks like that, okay? This is just a little picture of a short wavelength with a high frequency. This is a little picture of a long wavelength with a low frequency. Dangerous, bad. Safe, good. Okay? So the different types of light. Which ones are considered to be dangerous? Here's your rainbow, your visible light. This is the only light that we can see. We can't see infrared. We can't see microwaves. We can't see radio waves. We can't see ultraviolet. We can't see X-rays. We can't see gamma rays. We only see the visible light in the middle. Now, there are some animals that can see ultraviolet, all right? But other than that, this is what we see. We can't see those. We can't see those. We have other ways of detecting these. We have other ways of detecting these. When they tell you you're looking at an infrared image, they took the infrared light and they converted it into light that you could see. You're not seeing the infrared, you're seeing a representation, a model of what the infrared rays or the ultraviolet rays look like. All right, when you're seeing pictures from outer space, they're taking these other types of rays and changing them into pictures that you can see. All right, we cannot see these. We cannot see these. We only see visible light. That's why it's called visible light. One final way to use this chart is if you know the frequency of the light, you can look up the type of light that it is. For example, the frequencies, again, are on the bottom of the chart. They're the numbers at the bottom of the chart. So, to the far left, you've got 10 to the 21st, 10 to the 20th, 10 to the 19th, etc. And then you've got your visible light. I'll draw that in here in just a moment. Here's your visible light. That's going to be over here. All right? And then on the right side, etc., you've got, right, for example, 10 to the 9th, right, 10 to the 8th, 10 to the 7th. It goes down to 10 to the 5th on that side. All right, now, on this particular chart, you would never use the wavelength of the light to identify the type of light. the frequencies are more accurate. So if you're given the wavelength of light, convert it to frequency. All right, so speed is going to be frequency times wavelength. If you're given the wavelength, convert it to frequency. The frequency is going to be the speed of light divided by the wavelength that they gave you. Get the frequency, and then look up the frequency of the light to figure out what type of light it is. All right, so now here would be an example. If you know that the frequency of a particular type of light, all right, is 4 times 10 to the 19th. That could be two different possibilities. Let's say 4 times 10 to the 21st. All right, 4 times 10 to the 21st. All right, that would be somewhere over here. All right, this would be times 10 to the 19th would be all the way through here. Then we start 10 to the 20th. So times 10 to the 20th would be all the way through here. So somewhere around here, all right, we're going to find 4 times 10 to the 21st. All right, and if you look on the chart, all right, that's going to show that 4 times 10 to the 21st would be gamma rays. All right, those would be gamma rays. Now, what if it was 4 times 10 to the 19th? What if it was in here someplace? If you look on the chart, all right, 4 times 10 to the 19th, right about here, right between 10 to the 19th and 10 to the 20th, if you go straight up, that could either be gamma rays or X-rays. They overlap a little bit. All right, now, try another one. All right, try, for example, all right, 2 times 10 to the 15th. Where does that show up on the chart? Well, all right, here's 10 to the 15th. If you go straight up from 10 to the 15th, all right, 2 times 10 to the 15th, you're going to see that those are ultraviolet rays. All right, so that would definitely be ultraviolet. So this one would definitely be gamma. And this one would be UV, or ultraviolet rays. All right, now, let's look at some of the visible light, all right, the different colors of visible light. All right, I'm going to make this larger, okay? Let's do one on this side first. All right, 8 times 10 to the 10th. All right, so if you go to 10 to the 10th, between 10 to the 10th and 10 to the 11th, you go straight up. This is going to be microwaves. All right, again, you're just looking up the frequency. Remember, the unit for frequency is 1/seconds, or hertz. All right, and that would go for all of the light we've looked at. So that frequency on this chart is identified as microwaves. All right, now, let's look at the visible light and the frequencies for the visible light. All right, so copying the chart here, you've got the dotted line that comes down, and then you've got this kind of a fan like that. All right, and over here, all right, now we'll draw these the right colors. Okay, and then we'll do the numbers in black. Right, over here, you've got violet. And violet light is between a frequency of 6.59 times 10 to the 14th, 6.59 times 10 to the 14th, and 7.69 times 10 to the 14th. All right, so from here to here, that's going to be violet colored visible light. All right, your blue light, all right, again, I'm just looking at the chart. All right, your blue light is going to be between 6.10 and 6.59 times 10 to the 14th. All right, your green light, I will fill in the other types of light here. There's green, there's yellow, I don't know if you can see that, yellow, orange, take my word for it that I wrote yellow there, orange, and red. Okay, so I'm going to start over here with the red and I work my way over. The red light has a frequency as low as 3.84 times 10 to the 14th. All right, then red light ends at 4.82 times 10 to the 14th. That's where orange light starts. Orange light ends at 5.03 times 10 to the 14th. That's where yellow starts. Yellow ends at 5.20 times 10 to the 14th. All right, so what you see is if the frequency is between this number and this number times 10 to the 14th, it's going to be red light. If the frequency is between this number and this number, I made that space a little too big. If the frequency is between this number and this number times 10 to the 14th, that's going to be orange visible light. All right, etc. Between here, it's yellow. From here to here, it's green. From here to here, it's blue. And from here to here, violet. So, what if, for example, I said, or you calculated, all right, given some information, you calculated that the frequency of the light is 5.16 times 10 to the 14th hertz. All right, where would you put that light? What color light would that be? Where does it fall in here? Yes, you see that that color there would fall between 5.03 and 5.20. So that would be yellow light. All right, if that's the frequency, that's going to be yellow light. All right, now try one more. Okay, if the frequency of the light was 6.75 times 10 to the 14th hertz, which is 1 over seconds, right? What color light would that be? Where does it fall in this frequency chart here? All right, what color would that be? Yes, 6.75 is going to fall between 6.59 and 7.69. This light would be violet. All right, this light right here would be violet light. Okay, so you see how this part of the chart works. No matter what frequency you've got, it's going to fall somewhere on the chart. All right, if it was greater than this, that's going to go into ultraviolet and X-rays, all the dangerous types of light. If the frequency is lower than this, it could be infrared, it could be microwaves, it could be radio waves, down that way, all right, etc. Remember, don't look up, on this particular chart, don't use the wavelength to look up the type of light. Convert it to frequency, right, and you always use the frequency. Always use the bottom of the chart to identify the type of light. Now, again, just a quick little summary. The name of the chart is the electromagnetic spectrum. Everything on this chart is a type of light. All right, so gamma, X-rays, ultraviolet, visible, that's all the colors. Infrared, microwaves, radio waves, television waves are all types of light. Again, radio waves are types of light. The radio waves move through the air, they go to your radio, the radio converts the light waves, the radio waves, into sound that you can hear. All right, so the radio waves travel through the atmosphere as light waves, then your little box, your radio, converts those radio waves, those light waves, into sound waves that you can hear. All right, so again, radio waves are a type of light wave. Everything on this chart is a type of light. All right, so you know that these equations that pertain to light pertain to this whole chart. All right, you've got equations like, for example, the speed of a wave is the frequency times the wavelength. All right? The energy of a wave is Planck's constant times the frequency. You could also do it this way. All right? The energy is Planck's constant times c over lambda. You could do it that way. All right? So all of these equations can be used, and then the answers compared with this chart. You can get information from this chart to help you with these equations. These equations can help you to get information to look up things on the chart. All right? So the electromagnetic spectrum is all types of light. Very useful chart. I'll see you in the next section.